All right, so here's an example, another example from the notes that we didn't have a chance to do in class, but that I thought I'd make a video of just in case you would like to reference it and use it to help you through your homework. So we're trying to factor f of x equals 3x cubed minus 4x squared minus 28x minus 16 completely, given that x plus 2 is a factor. So basically what we need to do is divide f of x by x plus 2. And the way to do that we did in class today was to divide it synthetically by using x plus 2, the factor, in its zero form. So x equals negative 2. So we want to set up a synthetic division problem where x equals negative 2, plugging that in to the polynomial with synthetic substitution. Okay, so we already know the routine for doing synthetic substitution. And because they told us that x plus 2 is a factor, we should get 0 as the remainder. We talked about how this is a remainder today when you're doing synthetic division, or as the function value, which we talked about previously when we do synthetic substitution. Okay? And that's what we expect because they told us x plus 2 is a factor. So now here are the coefficients for our depressed polynomial, which is 1 power lower than the original polynomial. Okay, so there's that depressed polynomial. And now we want to factor this because they told us to factor f of x completely. Okay, so our goal now is to factor this. And this is one of those trinomials with a leading coefficient that isn't 1. So we have to do multiplies to give negative 24 and adds to give negative 10. So those numbers would be negative 12 and 2. So you'll set up this factoring by grouping problem, 3x squared minus 12x plus 2x minus 8, and then you will factor by grouping. So you'll factor out a GCF out of each group. This will be x minus 4 left over. GCF here is 2. X minus 4 will be left over. And then our final factoring is 3x plus 2 and x minus 4. So those are our factors from our depressed polynomial, from this depressed polynomial. And then we can't forget that x plus 2 was a factor originally. So there it is. This is f of x factored completely. Then the last thing that they want you to do in the notes is to be able to graph it, because you know about its end behavior, and its end behavior is based on the leading coefficient and the degree of the polynomial. So the leading coefficient of the original polynomial, that's up here, your leading coefficient is positive 3. We don't really care much about the number, but we do care about the fact that it's positive. And then if it's even or odd. And this polynomial is odd because of its highest power, okay? So we know that its end behavior is going to be looking like this because that's what a positive odd polynomial looks like. And we also know that its zeros are at negative 2/3, 4, and negative 2. That came from my factors, so we know that we can come up with zeros from factors. We've done that before. So then our rough sketch, here's negative 2, here's 4, and negative 2/3 is almost to negative 1. None of these have a multiplicity of 2, so they'll all be crossing through. All three of these zeros will be crossing through. And then my end behavior, I can draw my little arrows on my graph, and then from there I'm just crossing through every 0. So here's a rough sketch of my polynomial.